All right, here's your homework on the law of sines. So law of sines can work with a right triangle, but it doesn't need a right triangle. And what we're looking for the law of sines is this. Do we know, and this is angle, angle, side triangle, or it could be an angle, side, angle triangle. So this is the two things we're looking for. This one happens to be an angle, angle, side triangle. That's what we're given, angle, angle, side. And I just want to find that missing side using the law of sines. So I first recognize the angle and the side that's opposite of it. So it's sine 98 over 23. We're just creating a proportion. And then the sine of 44 and the opposite side, which is x. And that's all we're solving for. So to get x by itself, we'd multiply 23 times sine 44. And then we would divide by sine 98. Use your calculator, and you get 16.1. So again, using the law of sines. So let's look again. This is what I'm looking for. So start with what you're given. So sine 52 and 31. So sine 52 and 31. Create the proportion. Now in this case, I need to solve for that angle that's opposite of x. But I know two of the angles. Now it's not a right triangle, so I'm going to have to use 180, take away 61, take away 52. So that angle that I really need is 67. So it's sine 67 over x. To get x by itself, you go 31 times sine 67 divided by sine 52. And that answer is about 36.2 meters. Number 3. Again, this is what I'm looking for. So what do I know? So I know sine 21 and its opposite side 35. I'm looking for x, so the angle is sine 101 over x. To get x by itself, you multiply and then divide. So it's 95.9 feet when you use your calculator. Number 4. I want to find this. So what do I know? So I know 39 degrees and 12. I need to know the angle there, but I don't know it. So to find it, I need to go 180, take away 122, take away 39. So that angle that I don't know is actually 19. That's this one right here. So it's sine 19 over x. And then to get x by itself, we're going to go 12 times sine 19 divided by sine 39. Use your calculator, and you get 6.2 kilometers. Number 5. So you're given information about a triangle ABC. So I'm going to draw a triangle ABC. And what do we know? Angle A is 40. We know A to B is 33 meters. We know B to C is 31 meters. And we know angle C is what we're looking for. So draw a triangle and label it. Recognize what you are given that can help you here. So in this situation, you have an angle, sine 40 over 31. Now, in this situation, we don't know this angle here. So all we can do is sine, and we can have a variable. So sine of big C over 33. So we don't know the angle. This is an indicator that it is ambiguous. There might be two answers that could work to make that triangle. So whenever you use the law of sines to find a missing angle, it is ambiguous. There could be, it could work, it may not work. It could work twice. It could work once, and we have to figure it out. So first of all, we need to solve it. So to get sine C by itself, we're going to go 33 times sine 40 and divide by 31. To get C by itself, we're going to do the inverse sine to undo sine here and get C by itself. So that's what you'd be typing in your calculator. Inverse sine 33 sine 40 divided by 31. So in your calculator, it won't give you both. It will just give you the one answer, which is 43.2. It will always only give you an acute answer, or it might say error, meaning there's no angle possible. But in this case, it gives you 43.2. So we know that's one answer. Now, there might be another one, or there may not. And how we figure this out is we add the two angles that we know, 40 and 43.2, and we subtract 180. It might be that you can't subtract 180. When you add these two angles, they already might be bigger than 180, and then there's not another angle possible because they have to add up to 180. But in this case, you can. So if I go 180 and I subtract 40 and subtract 43.2, what is left for that possibility of that third angle? And it's 136.8. So just recognize that there could be one answer, there could be one angle, two angles, or there may be no angles possible in this situation. So let's draw triangle ABC again. ABC. We know angle B is 110. AC is 14 feet. BC is 7 feet. And we're trying to find angle A. So start with what you know. So we know sine 110 over 14. We don't know A, so sine A over 7, and so I want to solve for A to begin with. So to solve for A, I'm going to go 7 times sine 110 divided by 14, and then to get A by itself, it's the inverse of that. So that's what I'm going to put in my calculator. 7 times sine 110 divided by 14. It will always give you an acute answer or maybe no answer. So in this case, the acute answer that you're given is 28 degrees. Now, if I'm looking for the other possibility, oh, I totally shoot this. Can I go back to one? This one. The angle that you're given is going to be the acute angle. To find the obtuse angle, you're just going to go 180 subtract the acute. So all I had to do is go 180 subtract 43.2, and that's the answer you're given. Then you have to add up 40, 43.2, and 136.8. When you add those three angles, it has to be less than 180. It is, so therefore it works. I'm going to go back and do this one right. So to find the other possibility here, we're going to go 180 subtract 28. So 180 subtract 28 is 152. That's the other possibility that it could be with the law of sines. But the problem is, if you go 110, 28, and 152, that is too large. It's bigger than 180. So the only possibility of that angle could be is 28 degrees. All right, turn the page. ABC. Angle A is 45. AB is 27. BC is 16. And we're trying to find angle C. So start with what you know. So that's sine 45 over 16 and sine C, which I don't know, over 27. To get C by itself, it is going to be the inverse sine, and you're going to cross multiply and divide. So 27 times sine 45 divided by 16. When you put that in your calculator, there is no answer. It is too large. So in this situation, there is no triangle possible with the information given. So that's the other situation that could happen. And again, you'd see an error message here as you type. So make sure you type it in right and know why there's an error. All right, triangle ABC. So angle B is 85, AC is 32, AB is 11. Find angle A. Start with what you know. So what do we know is angle 85 and its opposite side. I don't know angle C, but it's opposite of 11. To get C by itself, solving for a missing angle, its inverse sine, you're going to cross multiply 11 times sine 85 divided by 32. And that's going to give you the answer, 20 degrees. Now the other possibility is if you subtract 180 is 160. Now 160 is too big. It won't add up. It'll add up to be way too big. So the only possible angle is 20 degrees. But what I was looking for is angle A. But you now know C and B. So now the measure of angle A would be 180 subtract 85 subtract 20. and so you know that angle is 75 degrees. So even if sometimes you can't find the angle you're looking for, you find the other one, and then understand that the three angles have to add up to 180. All right, number 9. Draw a triangle. Notice I'm not even really conscious of it being anything but a generic triangle. Angle C is 16 degrees, C to B is 24, B to A is 17. Find that angle. Start with what you know. So I know sine 16 over 17, and I know sine A over 24. To get A by itself, it's going to be the inverse sine. We're going to cross multiply. So it's going to be 24 times sine 16 divided by 17. So there's a possibility it could be 22.9. That's the acute. Then if I subtract 180, so I go 180 subtract 22.9, you get 157.1. Now we have to test that one. So 16 plus 157.1 plus 22.9. If I add those, right, what do we got? So we got 22.9 and 16. That's enough room for a third angle. 157.1 and 16. Is that less than 180? Yes, so there's room for another angle. So that means there are two possibilities for that angle. There it is. Number 10. We have triangle ABC. B is 144. A to C is 4. B to C is 9. And I'm trying to find this angle A. So I'm going to start with what I know. So sine 144 over 4 is equal to sine A over 9. Now I'm going to give you a clue here. I already know that there's nothing possible here. And the reason is the biggest angle in the triangle has to be the obtuse. There's no angle that's going to be bigger than the obtuse. Notice the side opposite of it is 4. The side opposite of the biggest angle must be the biggest side. So 144 is opposite of a side that is not the biggest side. 9 is bigger. That is impossible. 144 must be opposite of the biggest side, so therefore I know there's no solution. So you can solve for A, but just looking at the triangle and understanding the biggest angle is opposite of the biggest side. So therefore 9 can't happen. 4 has to be the biggest side. All right, two stories. A rocket is launched from Space Coast, Florida, and can be seen from local schools. The angles of elevation from Western High School and Pine High School are 41 degrees and 15 minutes and 23 degrees and 7 minutes and 30 seconds, respectively. If the two schools stand 512 miles apart, how far is the rocket from Pine Hill High School? So let's draw this situation out. So we have one high school, Western High School. We have another high school, Pine High School. And we're trying to figure out how far apart they are. And what we know is there's a rocket that was launched. There's my little rocket. And we know the angles there. So one angle and the other angle. So 15 minutes is a quarter of an hour. So it's 41.25. This one, 7 minutes and 30 seconds. That's 7.5 out of 60. I'd use my calculator and get 0.625. Is that right? No, 0.125. Is that right? 7.5. .125. So it's 23 and 1.25. All right, I want to find that big angle up there because this is what I'm looking for. So for that large angle up there, so we know the two schools are, 512 miles apart. I need to know that large angle. So I'm going to go 180 subtract 41.25 subtract 23.125. So if I do that math, what is that large angle up there? It is 115.625 degrees. So that's that large angle up there. 115.625. So I want to find how far the rocket is from Pine High School. That's this one right here. So I'm going to label that X. The rocket to here. So I'm going to start with what I know. So sine 115.625 over 512. And then what I'm looking for, the angle is going to be 41.25 and then X. So to get X by itself, I'm going to cross multiply and divide. So it's 512 times sine 41.25 divided by sine 115.625. So that's what you're going to type in your calculator, and you get 374.4 miles. That's how far the rocket is from Pine High School. This is what you put in your calculator. All right, here we go. So 3 lines of crops in a garden form a triangular shape. The strawberries are planted in a 10-foot line, and green beans are planted in an 18-foot line. So one's 10 feet, one's 18 feet. The third side is pumpkins, and they make an angle of 68 degrees with the strawberries. So that's the strawberries. So that angle there is 68 degrees. And then the question is, what's the length of the pumpkins? That's that one right there. So we're going to go sine 68 over this. What was that? 18. And what else do I know? Well, I got to label this. So I need to know that angle right there in terms of that angle. So I'll call that A right there. So that angle A over 10. So to get that angle by itself, it's the inverse. And I'm going to go 10 times sine 68 divided by 18. So when I find that angle, I get 31 degrees. Or the other possibility is 149. But 149 and 68 is too big. It's beyond 180. So the only angle it could possibly be is 31 degrees. So then I can go 180, take away 68, take away 31, and get the angle I really need, which is 68. No, 68 take away 31, take away 180. What the hay is left? So it's 81 is what's left. So this angle up here is 81. So then I have to do it all over again. So I need to set it up now to find X. So it's sine 68 over 18, sine 81 over X. And then to get X by itself, you multiply 18 sine 81 over sine 68. Use your calculator when you put that in, and you find the answer is 19.2 feet. All right, you trig experts. GMath, over and out.